So very good morning to Ananda. Today we are going to see about webinar on the big data analytics. Okay. So before we enter into the session, I like to introduce myself. My name is Kamalesh. I am from Pantech Solution. I am a senior project engineering software engineer. So I'm working in projects like data scientist, machine learning, deep learning, and then AI technologies. Okay. So today we are going to take see about big data analytics, and then this program is sponsored by C. Abdul Hakim College of Engineering and Technology. Okay, so this program is conducted by, that is organized by Department of Computer Science Engineering, and then thanks for this convener and coordinators to giving this wonderful opportunity, combining with C. Abdul Hakim College of Engineering and Technology. Okay, so this is the overall thing. So today we enter into the session of big data analytics, and we will see about how we can use our big data nowadays, and what are the previous years they are using big data, what is the trending one now we are using. Okay, so before we enter into the session, I like to tell about my Pantech solution. So its origin 2004, and then 7 branches like Chennai, Kerala, Telangana, Vijayawada. So like that we have organized different type of 7 branches, and then 100 plus employees, and then 2,200 workshops plus 1,500 approximate students. We conducted the workshop approximately. So our main aim is R&D for industry projects. Okay, so we will work for both industry projects also and college projects also, like machine learning, deep learning, or AI related projects, and then faculty development program FDP. We are specially it's like a workshop we can conduct for faculty development program, and hands-on training workshop, and then internship and in-plant training, and then short-term course, and then value-added course, then academic project training, and then customized design service and state of R&D. Okay, so these are the areas we are covering, projects related to both real-time R&D research and development also, and then academic wise we are sponsoring for both engineering students and MCA, MBA, like the different colleges degrees also. Okay, so the mainly we are focusing of ECE, EEE domains, and then CSE and IT domains. Like ECE and EEE domains means we are having IoT, artificial intelligence, embedded system and robotics, VLSI, FPGA, and TMS process, image processing and OpenCV, network simulation, power electronics, and electric vehicles. Okay, so next another one, CSE or IT domains like big data, data analytics, Internet of Things, and then Python, Android, Kotlin, Android applications like development, data image text mining, cloud computing, and mobile computing. Okay, so these are the area we are covering of CSE and IT domains. Okay, so let me enter into the session. So today's session, the table of content is like introduction to big data, and then what is Apache Spark, introduction to Apache Spark, and then applications and libraries of Apache Spark, and then what is data science and where we are implementing the Apache Spark in data science field, and then application and partition of Apache Spark, then how to set up one Apache Spark, simple Apache Spark. Okay, so these are the area we are covering in today's session. Let me enter into the introductions of big data and big data problems. Okay, so before we are enter into the system, we need to know about what is big data. Okay, so why we are using big data, how we are using big data. Okay, so what is big data? So big data is nothing but we need more number of memory space. Okay, like in gigabyte or in terabyte, in petabyte and exabyte and in zettabyte. Okay, so these are the so where we are using, like we need, if we have more number of data, okay, we need to store those data into somewhere. Okay, so those data in the form of GB or DB, any type. Okay, so we need to save, and the main aim of the big data is that one. Okay, and another one is why we are using. Okay, so we are using like web 2.0 and social sites, unstructured and structured data and analytics. Okay, Web 2.0 means for using internet access. So in your mobile phone itself we are accessing some internet. Okay, so like for that purpose. And social sites is nothing but like we are using Instagram or Twitter or Facebook. Okay, so these are some social sites. Okay, we are covering these social sites. Unstructured and unstructured. Okay, so structured and unstructured data means if you want to collect the data, okay, based on your usage, okay, so that should be in the form of two type. Okay, one is unstructured data, another one is structured data. Okay, structured data means it's in the form of like a one frame. Okay, in the for example, you have one photo, means for that photo you are framing, okay, something. Okay, like that same thing only for data they are framing. Okay, so what type of framing is like number of rows and columns with attribute names. Okay, that is called structured data. Okay, if you are move on to unstructured data, we don't have exactly data information. Okay, so it will be have some null values, or it will be have some other null values, or some other fields will be comes to those column. Okay, so it's not in structured form. Okay, so that is called unstructured data. Okay, so this both are available in big data community. Okay, in big data we have both unstructured and structured data. Okay, so mostly 20% of data only we have structured data in big data, and we have mostly unstructured data only 80% in this world. Okay, so using those data we need to do some analytics. Okay, that is called data science or machine learning or deep learning. Okay, so using those data we need to do some other processing like data manipulation, or converting into a data frame. After converting into a data frame we need to do some pre-processing. After pre-processing we need to do some analytics. Okay, so analytics is nothing but it's to plotting a graph. Okay, like chart or bar. Okay, like that we need to plot the graph. Otherwise then like some machine learning side. Okay, so machine learning or deep learning. Okay, we need to use any these two algorithms, we can find them accuracy result. Okay, so this is the thing we are doing in big data. Sorry, why we are doing in big data, this thing. Okay, then next one, storage. Okay, storage is important and processing is important. Okay, storage we have lot of storage. Okay, not a problem. And processing. Okay, processing is the important one. Okay, so we have data with more. Okay, not only with like a MB or KB. Okay, so it's having like a gigabyte, a terabyte or petabyte type of data we have. Okay, we need to process those data and store it in somewhere, or we need to process those data for some other analytics type. Means we need some like we need some system. Okay, we need some systems like high-ended software system to process those data. Okay, so at that time only we are using two type of softwares like Hadoop or Spark. Okay, so these are the two type of technology. Okay, using this technology we can access our large amount of data with more effective and more reliability. Okay, so here I am telling you to two systems are telling like Hadoop and Spark. Okay, so Hadoop and Spark is the one of the famous one. Okay, and then nowadays the trending one is Spark. Hadoop is older one. Okay, so let me see about both the two software. Okay, not a problem. So this is called big data. Okay, so large amount of data that will be stored in cloud or some other server. We need to retrieve those data, means we need some softwares, and sorry, we need to store those data, means we need some storage space. And then after storing the data we need to retrieve the data for data analytics. Means for that purpose we need some softwares. Okay, those software is also is mainly they called as a Hadoop or Spark. Okay, not only Hadoop or Spark, we have more on, but the most popular one is Hadoop and Spark. Okay, so big data characteristics. Okay, so totally big data have three characteristics. One is volume, velocity and variety. Okay, so volume in name itself suggests that size, amount, quantity of data, like that. Okay, and then velocity. Okay, velocity is speed of the data. Speed of the data means if you are passing the if you are retrieving or manipulating some data, okay, we need to achieve within the speed. Okay, those tasks want to achieve within the speed. Okay, that is velocity of the data. Then variety of data. Okay, type of data to be stored or processed. Variety of data means basically they will call us a structured and unstructured. In structured and unstructured, they are dividing into different type of parts. Okay, so that is variety of data. Then big data problems. Okay, what are the problems we are achieving in our big data? Okay, so first one is power of computers. Okay, so if you want to do big data process, we need some stuff like supercomputers. Okay, so with this normal your PC or normal PC you can't do with big data process, so you need some supercomputers. That one is one problem. Another one, each year new processors were able to perform and operation faster, and applications will be top of the automatically got faster. Okay, so why we are one of the problem is each and every year we having a new concept of PCs and new processors and new technologies are improving. Okay, so based on that our applications also we need to improve, that is our software side also we need to improve the thing. Okay, so that is the most data problem. And another one is each and every day we are having some unexpensive collected data. Okay, so that will be stored in vast amount in the each and every day we are giving some unstructured data to the server, so to the clouds. Okay, like we are using Instagram and Facebook and all. Okay, so for that purpose, that are based on cloud storage based only. Okay, so we are giving more number of data to cloud or big data. Okay, so that is the problem. And we have more data available, like we need to process those data, we need some large parallel computation clusters. Okay, so for example we have more data. Okay, we need to compute those data means we don't need only one computers. Okay, we need cluster of computer to process those data. Okay, so we need to connect with each other. Okay, each computer. Okay, so that is the most complexity. Okay, complex one, we need to attach all the thing. Okay, so that is the one thing we want to do. Okay, next one we will see about what is Apache Spark. Okay, so Apache Spark is nothing but it's a it's a computing engine. Okay, so it's one type of computing engine, it is only used for big data analytics only. Okay, so computing engine to process the data with cluster of computers. Okay, it's one type of Apache Spark is one type of engine. Okay, those engine will be set to all the computers that is within node. They will connect with each other within cluster. They connected with each other, and then after that they will process the data. Okay, so in big data. Okay, that is this called Apache Spark. Okay, so Apache Spark is the main for big data problems. Apache Spark is the one of the major solution. Okay, so we can using Apache Spark we can retrieve the data from the big data, or we can fastly you can store the data to the storage also. Okay, so like we can use the storage like Hadoop MapReducing. Okay, so Hadoop MapReducing is one of the oldest storing of data, but we have another one new also. Okay, so about this we will discuss in coming presentation. Okay, first one is why Apache Spark. Okay, so why we are using. Okay, so Apache Spark is like we know already it's an engine, and then it will improve the efficiency. Okay, like memory data sharing or general computation graph. Okay, so compared to any other any other engine. Okay, so Apache Spark will be 100 times faster, okay, like memory sharing also, or general computing graph also. Okay, so if you want to view some of the graph, some of the data analytics graph using your big data, means it will be give the graph as soon as possible with 10 times faster, sorry, 100 times faster. Okay, and then memory data sharing also. Memory data sharing means if you want to share the data from one place to another place, or any other data also, it will be compute most speedable. Okay, and then usability. Okay, so we can use our Apache Spark with different type of APIs. Okay, APIs like nothing but it's like a Java or Scala or Python. Okay, so these are some of the APIs. You can connect those, you can use that APIs, and then you can run the Apache Spark. Okay, and then we have interactive shell. Okay, so nowadays most of the ideally will be comes to interactive shell type. Okay, then only we can easily understand the code, and we can easily implement the code, and easily we can run the code without any errors. Okay, so that is one of the main advantage. Okay, so when we compare to any other APIs, the Java, Scala, Python, if you use those type of languages, means it will be reduce the code sizes also. Okay, 10 times Python will be 10 times smaller when compared to any other coding language. Okay, so that is the main advantage of the usability. Okay, Apache Spark. Okay, so here you can see the some basic engine. Okay, how it's working. Okay, so Spark SQL structured data, and then Spark streaming real timing, where we can use. Okay, so here in downside we have an like different type of open source database. Okay, so using that database we can connect our Spark software. Okay, that is Spark engine. After, if you connecting the Spark engine with those database, you can use Spark SQL structured data and Spark streaming real-time data and machine learning library, and then GraphX. Okay, let me see the core architecture of each one. Okay, so about Spark SQL structured data, it's nothing but like if you want to save your own structured data, own structured data or unstructured data, structured data only. Okay, structured query language. Okay, structured data only. So if you want to store those your data to the MySQL format, means you can use, otherwise Spark streaming real time. Okay, streaming services also it will be used. Machine learning libraries. Okay, so machine learning libraries, like in Python we have libraries like sklearn, scipy, or keras, tensorflow. Okay, so these are the libraries it's available support by Spark core. And then GraphX is nothing but like visualizing the data with the graphical manner. Okay, so in for example, if in cricket they will plot some graphs. Okay, what is the team A and what is the team B. Okay, what is the comparison between team A and team E, like that they will use some graphs. Okay, so those graphs and all based on structured data only. Okay, so using those structured data they can plot the graph. Okay, so if you take a Python language, we have a plotting libraries like Matplotlib, Cborn. Okay, Plotly. Okay, so we have more number of plotting graphs also available. Okay, then let me enter to the ecosystem. Okay, so ecosystem is nothing but from the starting to ending. Okay, what type of if you want to use SQL, if you want to use Apache Spark, what type of thing you need to do. Okay, so first we will comes into the programming language size. Okay, so in programming language we can, if you want to use Apache Spark, you can use Scala. Okay, this is one of the main programming language. Okay, so mainly for Apache Spark. And then Java, everybody will know about this Java. And then Python, and then R. Okay, so R is totally it's like a Python only, but mainly the R is introduced for data analytic purpose. Okay, so you can use R language for data analytic purpose, or you want to use machine learning or deep learning data analytic purpose also, Python available. Java we can use like Hadoop systems, and then Scala mainly for Apache Spark. Okay, so these are the programming language you can use. And then libraries, what type of libraries we can use for each, like Spark SQL. Okay, for structured query language you can store Spark SQL. Okay, and then Spark ML library. Okay, so the machine learning library, if you want to use, you can use Spark ML with GraphX and Spark streaming. This about this library we already before slide we seen. Okay, next one we are having Spark engine here. After Spark engine, we need to we have two things. One is management and storage. Okay, so management is nothing but if you are giving any task to any library fields. Okay, so according to the data it will be give the output. Okay, so those data managing and then those data retrieving from the database under doing this management group. Okay, so in management group we have yarn and MESOS and then Spark. Okay, Spark. Okay, so this is management group. Then at last we have a storage. Okay, about storage everybody will know, like local FS, HDFS. Okay, so and then Amazon S3, RDBMS, and then NoSQL. Okay, so these are the storage purpose. Using this you can store your data. Okay, so this is the overall ecosystem of, if you are using Apache Spark, we need to install those packages and libraries, and then you are familiar with those languages also. Okay, so about Spark, it's a large community. Okay, so in past year the Spark users will be more when compared to like MapReduce, yarn, HDFS and Storm. Otherwise the line of code also changed when compared to any other languages also. Okay, so this is one of the Spark is a large community. Okay, so based on that they will act. Then introduction to Spark. Okay, so if you want to use Spark, okay, so why a new programming model? Okay, so if you want to use Spark, okay, Spark is mostly used to map reducing data analytics. Okay, so what is map reducing? Okay, I from starting inwards I am telling you two guys about map reducing. Okay, I will tell you what is map reducing in next coming slide. Okay, so next one is complex, interactive and real time. Okay, so complex. Okay, so why we are using Apache Spark means if you have more number of data. Okay, in machine learning, using those more number of data, training of machine and plotting of graphs is difficult. Okay, so for that purpose we are using a we are using Apache Spark. Okay, so if you are using Apache Spark, we can build a machine learning model also, or you can plot the graph also. Okay, so that is the one of the thing, complex type. And then interactive ad hoc queries. Okay, interactive ad hoc queries means like we can like whatever queries you need. Okay, during your ad hoc means nothing but it's a temporary. Okay, so temporary queries. Okay, so if you need any temporarily any queries means you can use these interactive queries. And then real-time streaming process. Okay, you can use real-time streaming process. So this is the most thing we are using for Apache Spark. Okay, so here you can see world sharing MapReduce. Okay, so what is the world sharing techniques in Apache Spark, or sorry, in big data means we have map reducing technique. Okay, so this is the technique we use in Hadoop system. Okay, so first you can see the input area. Okay, so welcome to Hadoop, class Hadoop is good, Hadoop is bad. Okay, so here I am passing for example some data. Okay, those data in string format. So after I am passing this input data, next those input data will be divided into different type by line. Okay, so welcome to Hadoop, class Hadoop is good, Hadoop is bad. Okay, so input will be splitted. After the splits, we are checking the how many times repeating of each word, that is called mapping. Okay, for example, welcome to Hadoop. Okay, so each words will be repeated for one time. So welcome to welcome 1 to 1 Hadoop 1. Okay, so likewise we are taking next line and next few lines also. Okay, then after this mapping, then we are entered into the shuffling. Okay, so shuffling is nothing but we are shuffling our mapping data into an some other like same data. Okay, so for example, the word Hadoop we are using in 3 mapping session. Okay, so we are taking as a each of the 111. Okay, so each of them, okay, each will be repeated for 2 times, so taking that is called shuffling. Okay, so after I am shuffling, I am doing my reducing. Okay, so map is nothing but we are mapping each word into an how many 111, and then reducing is nothing but we are repeating words will be reduced uh, into counting values. Okay, so bad means 1 and class means 1, like Hadoop means 3. Okay, so after I am doing map and reducer, then I will be store those data into some other way, some other storage purpose, some other storing data like a server or cloud. Okay, so this is the called map reducing. Okay, so this is the word technique. Okay, so we in Hadoop systems we are using, but in Spark we are using different way. Okay, like based on RDD we are using. About this I will tell you. Okay, so next here you can see we are using data sharing in RDD. Okay, like in Apache Spark. Okay, so here you can see I have a list. Okay, so those list from 1 to 99 numbers. Okay, so those numbers will be splitted 1 2 3 4 5 6 7 8, totally 8 type of RDD we are splitting. Okay, so using this uh, we are doing a memory storage. Okay, so what we are doing means we are using totally 2 type of storage. One is master, and then we have worker. Okay, so about RDD is nothing but resilient distributed data set. Okay, so resilient distributed data set, this one. Okay, so it's a fundamental data structure of Spark. Okay, so we are using, if you are using Spark, it is just a fundamental data structure. It is a immutable distributed collection of object. Okay, so immutable. Okay, immutable is nothing but like we have like mutable and immutable. Okay, mutable means the data which we are stored in RDD, we can replace that one and we can change. Okay, that is called immutable. For example, here I am having a first RDD row. Okay, in this row I am taking we have a number from 1 to 17. Okay, so within 1 to 17 I will remove some other values and I can add some other data, like that is called immutable. Okay, if you have an immutable, so we can't do anything. Okay, so if you altered the address of the variable from 1 to 17 as a 001, so address of the variable we can't change anything. Okay, so that is called immutable. Okay, so RDD is a immutable distributed collection object. Okay, so based on the fault tolerance, it will be can try to retrieve the data. Okay, that is the main point of RDD data sharing. But in Hadoop we can't do like this. Okay, so here you can see randomly all the RDD data will be stored in workers database. Okay, so this is random, not we are not we are giving as particularly. Then after that it will be checked connected to the master. Okay, so this is the thing we are doing in RDD sharing. Okay, so what we would like means, for example, each and every iteration. Okay, so we getting a data, same data only. Okay, so here you can see we have only we have one memory, that is distributed memory. Okay, one time processing only. So based on the different type of queries, we are dividing. So for n number of tasks we can achieve. Okay, so that is called faster than the network and disk. Okay, so that is, here we can see we giving customer 1 giving asking some task, customer 2 asking some task, and customer 3. Okay, so based on the distributed memory, each one can retrieve the data without any thing. Okay, so that is the main matter of Apache Spark. Okay, so about RDD, the collection of objects that can be stored in the memory disk, built by parallel transformation. Okay, and then automatically rebuild on failure. Okay, so each data during each transaction or each processing, they have some data of data, that is that they have some metadata. Based on that metadata, if anything will be happen during an processing or during transferring, using that metadata, it's try to retrieve the data, original data. Okay, that is the main advantage of RDT. Okay, so for example, log mining. Okay, so log mining is one of the major example. So we are collecting the log data. So log data will be based on collecting the data from based on the sensors. After we are collecting that based on the sensors, we are cleaning the data and converting into the structure form. Okay, so converting into the structure form means we are converting those log data into the column wise and row wise. Okay, that is called data frame type, and then after that we can obtain the data analysis and result. Okay, so this is the example of log data, log mining. Okay, then fault tolerance, I already told to you, if RD will be track the transformation used to build them to the recompute the last data. Okay, so each and every transformation RD will build some lineage. Okay, lineage means for example, they will build some metadata. Based on that metadata, if any data will be lost during transformation, it will be automatically retrieve the data. That is the called fault tolerance. Okay, so here you can see, here I am applying a logistic regression algorithm for my data. Okay, so we are comparing my Hadoop, okay, Hadoop with MapReducing technique and Spark with RDT technique. Okay, so here I am implementing. Okay, so each and every iteration you can see the running time. Okay, so x-axis will be represent the running number of iteration, that is first iteration, 5 iteration. Totally I am doing 13 iteration, and then we in y-axis we have running time. Okay, so you can see the here first time it takes some few minutes. Okay, so in first iteration it takes some 80 seconds only. Okay, 80 seconds it take, but later iteration it take only a few seconds. Okay, each iteration it take a number of seconds, it take a 1 by 10 iteration, it will be taken only a minimum number of seconds to retrieve the data. Okay, for logistic regression algorithm. So logistic regression algorithm is one of the classification algorithm in machine learning. Okay, it comes under supervisor type of learning. So I am using that supervisor type of data set. I am using the Spark. Okay, so this is an example. And then disk performance also you can see, compared to the Hadoop, we have a disk performance like it's reducing. Okay, so if you want to compute any Hadoop type of data record, means you need more than 200 machines we need. Okay, that is 200 cluster of computers we need to compute one process. Then it takes 72 minutes to give the output. Okay, but in 2014 Spark will be recorded within 207 machines. It will be give the result for 1 TB of data. Okay, so for 1 TB of data it will be 200 times it retrieve the message, that is 23 minutes. Okay, so this is the basic difference between 2013 and 2014. Okay, that is Hadoop and Spark. Okay, so Hadoop will be Spark will be supported for not only for like MapReducing, not only for RDT type, we can use some other different operations also, like map filtering or group 5 union reducing take. Okay, so these are the pipeline. Okay, so about pipeline I will explain you. Okay, what is pipeline? Pipeline is one of the more important technique. Okay, so you can easily understand, it's easily understandable, and you can easily reduce the coding line also. Okay, so that is one of the technique. And then user community. Okay, so Yahoo, eBay, IBM, so these are the area we can cover with Hadoop system. And Databricks. Okay, so using Databricks only today I will tell you how you can create on Apache Spark through online itself. Okay, without any installation of software, you can check it. Okay, so we have totally 800 nodes like on PB and single jobs over on PB. Okay, so this is the user community. Then applications and libraries. Okay, so what are the applications and libraries we have? Okay, so application is nothing but it support programming language Python, Scala, Java, we already know, and it support SQL tasks, structured query language also we can install. it enables data streaming, and it can be run on single machine or cluster of computers. Okay, so within cluster of computers also it will be give the result on single machines. Okay, so mostly it will be used for machine learning and deep learning. So this is the application. This about this we already seen. Okay, so next one, libraries available in the Spark system. Okay, so these are the core libraries we can available in Spark system. We can check it one by one. We can see one by one. Okay, first one is Spark SQL, and then Spark SQL, it can be applicable for both SQL type of storage and JSON file. Dataset is nothing matter. Okay, so we can give the data with here I am using schema plus data. Okay, so schema plus data, we have a code. Okay, so using schema we are retrieving the SQL queries and the JSON files. Then Spark streaming. Okay, so Spark streaming will be prepared using RDD. Okay, so using RDD we can retrieve the data like Twitter, Twitter hashtags. Okay, so if you give any hashtags related, means you can give the, if you can retrieve the data from Twitter also using API keys. Okay, so Twitter will give API key for developers. Using that developer API key you can check it out. Okay, then machine learning libraries like K-means algorithm or random forest algorithm or any other algorithm. Okay, so you can using vectors and metrics also. Okay, metric is nothing but if you want to get an accuracy score or confusion matrix score, you can use metrics or iterative comparison. Okay, so like this machine learning library also it's useful. And graphing. Okay, so to plot the graph like line chart or bar chart. Okay, so like same like thing we can use for RDD. Okay, so next you can see here performance and specialized engine. Okay, so what is the difference between where we can, so for example up to now we have studied about SQL and streaming, data streaming and machine learning. So we are comparing with some other packages also like Impala disk and Spark disk. Okay, so how it's working. Okay, for SQL. Okay, for streaming we have only two, one is Storm and another one is Spark. Okay, so compared to Storm we having more MB. Okay, speed. Okay, more per second, we have more number of speed like 75 MB per seconds. Okay, so we are getting streaming compared to Storm. Okay, so next one is response. Okay, how you are after training the algorithm, how you will get the output. Like in machine learning you can use like package like MapReduce and then GraphLab and Spark. Okay, so this will be response level will be quick compared to that machine learning. Like, so if you are using MapReduce, they taken more than 40 minutes to response. Okay, but if you are taking a GraphLab or Spark, it's almost same only, but compared to GraphLab we are getting response time soon. Okay, so that is the in machine learning. Okay, so this is the performance of Spark. And then combining process. Okay, so combining process means you can easily run the like for example you can see here I am loading a data. Okay, after loading a data, here I am passing the both data and then input also. Okay, so you can combining the process also. Okay, not only we can't do with single by line. Okay, you can combine process easily. Here you can see separate engine and Spark engine. Okay, so if you are taking any other separate engines like HDFS, we need to do predict preparing the dataset and train the dataset and applying. So this is called a pipeline. Okay, so here you can see like some other engine means we need to do pre-processing separately and then training separately and then applying the algorithm separately. Okay, so we need to do write the code for both the three steps. Okay, but if you are using Spark, okay, with Python or Scala, you can easily write the code after reading the dataset for pre-processing, training and applying an algorithm. Okay, within single 2 or 3 line we can write the code using pipeline technique method, and then we will get the output. Okay, so that is the called combining process type. Okay, next one is data science part. Okay, so here I need to tell about data science part, and then where we can use the data science part in some other out platform. Okay, so other side platforms also. Okay, so first we see about what we can do with data science, and then next one using API what we can do other platforms also. Okay, so we will see here. You can see the beyond map reducing, we have yearly we are using Hadoop user, everybody will know. Okay, but here now we are using like data statistical method, or like R using, okay, like Python data, or we are using some data science part. Okay, so if you are using Python data, or sorry, if you are using R programming language, or machine learning type of code, okay, you need to use data frame. Okay, so data frame is the method. Okay, so if you are taking a machine learning, we are using data frame method as a pandas. Okay, so pandas is a library package to reading the input data set. Those data set should be in the form of data frame. Okay, so for R we have separate library package. Based on that you need to use train the algorithm. Okay, so those thing we can done with Google data, we can done with data frame. Okay, then you can see here, this is the difference graph. Okay, so like Python, how we can using a data frames and Scala, and then Spark. Okay, so this is the data frame technique we are using, and machine learning pipeline technique. So about pipeline technique I already told to you. Within single line you can do all the process. Okay, so here you can see we have a data frame have more number of rows and columns. Okay, so these data will be converted into the tokenizer, that is word by word we are converting. Tokenizer is nothing but word by word converting. After word by word converting, we are using TF. Okay, so TF is nothing but count vectorizers. Okay, so in vectorizers we have different type of vectorizer we have in machine learning, like count vectorizer, hash vectorizer, and TFD vectorizer. Here we are using TF vectorizer and logistic regression model. Then we are within single line itself we are training the model. Okay, so that is the use of pipeline techniques. Okay, so using pipeline technique, here I am applying the model. Okay, so here you can see the program. I am tokenizer function, I am saved in one variable. Hashing TF function will be saved in one variable, and logistic regression algorithm will be saved in one variable. Okay, so here I am using pipeline technique. Okay, so I am passing all the functions. Okay, so like tokenizer function and TF function, so it will be stored in pipe. Okay, so after it will be stored in pipe, I am using fit is the keyword to train the algorithm. Using fit is the function to training the algorithm. So I am passing the variable data frame. Okay, so data frame is nothing but data which we have. Okay, so those data will be trained the model, and then those trained model will be stored in model variable name. Okay, so this is called machine learning pipeline technique. Okay, so same thing we can do with R interfaces also. Okay, so like this, using JSON file you need to do. Okay, so then platform interface, how we can interface our data science part into platform. Okay, so till now we have seen about how we can use data science in our local data frame data sets, but here you can interface your dataset with some other API keys also. Okay, so API key is nothing but they will allow they collect the data from the through internet. Okay, so like Flipkart, Amazon, or Twitter, you need some data related to like for example, if you take a Flipkart, I need an iPhone mobile details from starting price to ending price. Okay, so I need the data set of that mean using HTML file you can retrieve that data. Those data will be saved in data frame model. Okay, so for that purpose we need to do web scraping. Okay, in Python. Okay, so using that web scraping we will collect the data. Okay, so that is called API, and so for that purpose also we can use, okay, for API source type of data. So those data will be stored in SQL type of storage only. Okay, so data frame which we are getting from the online, it will be stored in SQL format, and then they have more number of built-in files also and community also, like CSV, comma separated values, okay, and cloud storage and Hive JSON. Okay, so using those current data source you can retrieve the data. And then if you want to install Spark, you can for your computer you need to use this spark.apache.organization. Otherwise, if you want to try the Spark in cloud, you can use databrick.com. Okay, so I will tell you how you can install this databrick.com, how you can access your databrick.com in your PC. Okay, so today's session. And then Spark Summit, you have this one. Okay, so PySpark applications and partitions. Okay, so PySpark have totally three partitions. Okay, one is driver process, another one is executors, another one is cluster manager. Okay, so driver processor is nothing but like they have three main tasks. One is hold the information, another one is respond the input, another one is analyzing the distribution of schedules. Okay, so that is called the information means if you are giving for example, we have one community, big data PySpark community. Within that community you are giving some task to PySpark software, like so that is called one information. Okay, so you are giving some task, so those tasks will be stored in some information way, that is the use of driver. Okay, so after if you pass any task, okay, they need to respond according to your task. Okay, so those respond will be distributed into according to the schedule wise. Okay, so before that, if you anybody give you the task means they will done the task, then only it will be take as a next as a your task. Okay, so like that the handling of task and all done by drivers. And then executors. Okay, executor is nothing but the task will be executed by assigning task will be executed by executors. And then cluster manager. Okay, so if cluster manager is nothing but according to the task given, those output will be splitted according to the first come first serve. Okay, like that. Okay, so who are all asking according to the first come first serve wise, managing wise, it will be give the cluster manager. Okay, so then how to set up then and run the Apache Spark, let's we see. Okay, so next, first of all, you want to go to this .com, databrick.com. Okay, so on try Databrick, this website is important. Okay, after you entering this website, okay, so next it will be ask otherwise you can go with databricks.com. then after that you enter into an try Databricks option. Okay, you have a try Databricks option, just to you click that one. You have two options will become, one is get started or community edition. Okay, so get started means you need to pay some amount to create on it's a free trial only, but you need to pay some amount. Otherwise you can use community edition, it is easy to start. Okay, easy to register and it is easy to start. After if you click community edition, get started community edition, it will be asked if you are login with your Gmail account, just to give your Gmail account. Okay, automatically it will be login with your Gmail account, then it will be show like this. Okay, so like this you can create a new notebook. Okay, and then you can build the Apache Spark. Okay, so some of the basic operation with Apache Spark: data processing, build the data processing and pipeline, and build the classifier and train and evaluate model. Okay, so these are some of the basic operations we are doing in by step. Okay, so for that purpose you need to click this new notebook. Okay, so using this you can retrieve the data. So what is the basic operation? Let me see. Okay, basic operation is nothing but first one, you need to read the dataset. Okay, so those dataset will be not available in your PySpark. Okay, so PySpark notebook, so you need to just drag and drop your dataset. Otherwise you can create a new here you have an option like create a table. Okay, you can create your own dataset, some sample data like X, Y, Z and male or female, like that you can create your own dataset. So after this reading read those dataset, read the dataset. After reading the dataset, you will be I am reading here adult data.csv. After I am reading adult data, I am having like this native country and count. Okay, so totally I have 20 rows, and then here I am using pipeline technique to giving my df.trim, that is giving my data set to pipeline technique to train the algorithm. After I am training the algorithm, I am building the classifier. Okay, so building classifier is nothing but like I am importing an dense vector. Okay, using dense vector I am converting into the RDD type of data. Then I am training my data. Then after training the data, I am just viewing my training data. Here you can see train data dot group by label dot aggregate label count. So here I am totally 0th label I am having 19,698, and then 6,263 I am having totally. Okay, train data. So evaluate the data is nothing but you need to test the data. Okay, so to test the data you just need to pass your test data. Okay, then after that it will be give the output totally test data, how many zeros and how many ones. Okay, so about zeros and label is nothing but we have a data of adult. Okay, so here the data set is represent of I will show you, wait a minute. Desktop webinar. Big data, right? Big data science. Here you can see I have a data of adult data. If I see the adult data, you can see so who the age and work class, and then education, and then material status, like that, occupation. Okay, like gender wise. Okay, how much they are getting an income based on the result. Okay, so less than 65, sorry, less than 15k or greater than 15k or equal to 15k. Okay, so like that I am having a data set. I am using those data set in my to the algorithm and then training the result. Okay, so if it is a less than 50k, this is 0, and then greater than 15k 1. Okay, so for my test data, the less than 15k is like 5021 data will be less than 15k they are buying a salary, and then one is 1578 will be an greater than 15k. Okay, so like after I am testing the data. Okay, so this is what I need to tell you. So we have in online internships we are conducting, like these are the areas we are covering. Okay, so if you want to study about those internship, you can just at last I will give the numbers. Okay, you can contact those numbers, they will help you how to register the online internship. Okay, we are conducting with normal Pantech internships also, and then we have partnered with IETE. Okay, so the Institution of Electronic and Telecommunication Engineering. So if you need certificate with IETE Pantech internship program, you can contact and ask with IETE Pantech internship. Otherwise you need normal internship with Pantech internship, Pantech company also it's available. Okay, so for IETE we have totally two offers available. One is 1 month, okay, that is RS 4,200. Another is 5 days, that is 350 and 300. Okay, according to the domain it will be changed. Okay, so those who are interested to join, you can contact us. Okay, so if you need further more information about regarding this event or like internship related, you can contact on WhatsApp. Okay, 7010888841. About this webinar, if you have any doubt or regarding anything this webinar, you can contact me on hod.java@pantechmail.com. okay, so we got Telegram also, we got channel and Telegram also. Okay, you can contact on Pantech e-learning channel. Okay, so if you need internships or any other like internship or any other webinar like this, you can contact on these three members, like Mr. Senthil Kumar, Mr. Srinivasan and Mr. Kumarasamy. Okay, so thank you guys. I hope everybody will enjoy this session about big data analytics. Okay, let me see in another new session. So till now it's signing off from Kamalesh. Bye.